welcome to another episode of Drunk Astronomy.
Cheers!
Cheers. I'm Marvelous Mark. We have Atomic Tom, Jupiter Joe, and Maggie, who does not have a nickname because she is so special, she doesn't need a nickname.
That is correct.
Oh, we need to find her one, man.
Well, we'll work on that in another episode.
Magnificent Maggie.
Well,
yeah. Marvelous Matt. Wait, that's yours, or isn't it, Mark? Oh.
Yeah, no stealing money.
That's funny.
So tonight we're going to be talking about the JWST, which is also known as the James Webb Space Telescope. And we're going to try to figure out who the hell is James Webb and why does anybody care?
Don't tell the audience why nobody cares.
Well, they'll have to. This is a planting breadcrumbs. They're going to have to figure out why somebody cares.
I care. I actually read a whole book about James Webb in my Apollo time.
Hopefully you can tell us why somebody cares.
And let me just give you a quick rundown of James Webb. He worked for NASA, but he was located in Washington, D.C., and he secured all the funding for NASA. So NASA would say, we need, $1 billion. And everyone would say, what the heck? What do you do? Blah, blah, blah. And James Webb would say, yeah, come into my office, sir. I'll tell you why. That kind of thing.
So he was seen again.
Yeah, he was an integral part to getting the Apollo missions going and funded and on schedule as well. So that's who James Webb is. So he was a money guy.
Interesting.
No kidding. I thought he was like a scientist guy.
He might be a scientist too.
How much
as a money guy, he was excited enough to get a name.
Yeah,
exactly.
Let's talk at the same time. What, Maggie?
How much money do you have to give to NASA to get a telescope named after you? That's what I'd like to know.
Well, he's been dead for a long time, so I don't know. I don't know where the naming came from, but
did he give money to NASA or did he raise money for NASA?
He worked for NASA, but he grabbed it from Congress. So he was the point man to Congress.
Yeah, it's money guys. There's some upside here.
Also known as the bag man. He probably had, dirt on every senator.
All right, so let's go ahead and look at our first slide because this is the question for Maggie. Which one is the James Webb Telescope? And can you name the other telescope that's in the picture?
So one looks like the empty toilet paper roll.
Yes. The pin light camera, which it kind of is, yes.
And the other one looks like a honeycomb kind of.
Look at Joe's shoulder.
Okay.
Over Joe's shoulder.
Is that a hint?
Don't look right at his shoulder. Look at past his shoulder.
That might be
like a telescope would look past.
Okay, so I am going to go out on a limb, given the hints that I was given, that the honeycomb is the James Webb.
That is correct, Maggie. Good job. Bing, bing, bing. Okay, Maggie, you passed the first test.
Woo! I get to continue to play the game of.
Yes, you do.
Learn about James Webb Telescope.
Okay, now go to the second one, and that's that's just what it looks like in space.
Okay.
Which is, it's kind of a rocking, cool looking thing there.
Well, but I think one of the very coolest things about this is it didn't look like that when it took off.
Yeah.
Right? It essentially had to fit in a can.
Right.
And
a rocket, they call that.
Well, the rocket is the part that drives it, but there's,
Yeah. What was that, Maggie?
So then what happened? It got into space and it just exploded out of the rocket and became.
Yeah, you just add water and it poofs out.
Like a chia pet?
No.
The study of what is that when you fold fold paper all that way?
Origami.
Origami. That's ergonomics. No, it's not ergonomics. It's origami.
That's when your chair's comfortable, Joe.
But that is.
It's because
that's
your butt is shaped in
a huge
shape.
origami is a huge deal in science right now because, and this is a perfect example. Tom says, you know, you got to put it in a can and then fire it up into space, and then it needs to unfurl. And there's where the origami comes in. It's the engineered scientific origami deployment. Work with me, Tom.
I'm loving it, you know.
Well, I actually do think that whatever the material is underneath the honeycomb thing does look like sheets of paper kind of strung up kind of underneath one another. I'm not sure what that is, but
yeah,
if I were to describe it, that's kind of what it looks like.
Yeah.
Tom,
Yeah.
what's the function of that stuff on the bottom? Do you know?
Absolutely.
Okay, tell Maggie and the audience.
So one of the how many minutes do you want me to go here?
30 seconds, go.
No, okay. Well, the bottom line is that without all the context is it's to cool the thing down, right? And there's lots of interesting reasons it has to be cooled down, and then lots of interesting ways that it is cooled down. So so those are actually
it also
Mylar sheets.
It blocks the sun
Mylar sheets that are the sun shield, and there's you see the multiple layers in there, right? So each sheet is, it's funny because part of the unfolding was the sheets had to separate from each other, and this is all happening, you know, on the way to 1 million miles from Earth, way too far to ever get again, right? You know, like Hubble, we could go get it. You know, the shuttle took it into its bay and they added new cameras and they fixed it, you know.
So
this
Tom,
is
you know how all this
fix.
stuff works, but you're not really sure what 30 seconds is, are you?
No. You need a little clock here going.
Well, yeah.
That, you know, tequila bottle clock.
Yeah.
Well, it's sort of like, you know, when you're jumping out of a plane and skydiving, like you really want the chute to open, because if it doesn't open properly, you know, there's going to be a pretty bad consequence. Same thing.
Well,
you know what we call that now, Maggie? We call that less than optimal.
Well, but that's funny thing, right? Is when you jump out of a plane, you've got a chute on your back, and then if that one doesn't, the main one doesn't work, you've got another one in front of you, right? The secondary chute. Have you jumped out of a plane?
No,
I have.
Never will. I will watch other people do it happily from the ground.
Joe, well, you don't want to see him splat, though.
No, I don't want to see Joe splat.
That's my name of one of my bands. Come on now, 2 T's, iTunes and Spotify.
That's so funny.
Subscribe below.
Well, and so those do, as Tom is saying, they block the sun to give the telescope, Atomic Tom.
Well, and you know, merch available.
Yes, which you're gonna talk about. We're gonna talk about later, Tom, because you're gonna do it for us. So it blocks the sun, gives the telescope a nice black environment to look out in the stars, and it also has the solar panels which power the telescope. So it's both blocking and power. So let's go to the next.
I'm just having a really good time. Just everybody, I just want you to know I'm just enjoying myself.
Good, me too.
Well, and so are we. I think that's the funny thing is not the funny thing, it's the cool thing, right? We have fun doing this stuff. It's not just,
that's the idea.
It's not just science, it's fun.
It's not just to drink tequila. Oopsie, I said the D word. That means drink again. All right, so let's go to the next slide. And this is the comparison of lenses. Cheers. Ching.
Is comparison a drinking word?
Oh, the D word is a drinking. Oops.
Yeah. See how that starts? It goes downhill fast.
It does.
Um,
And we're just getting going too. So the comparison, you see the comparisons, right? You got a big one and a small one.
Not that
again-
size matters.
Oh gosh, here we go again. Pluto's a
I
planet.
so
dang it.
love you, Maggie. You just make me happy saying that. And
Yeah.
I'm also doubly, or I don't know, quadruply happy that you remember that, and that was an important truth that you shared.
That was one of our best episodes. Why Pluto is still a freaking planet. That's why.
Pluto is a planet.
Because it's round. That's why it was.
have we talked about the 10th planet yet?
Because size doesn't
No, but
matter.
let's do an episode on that
Size
because
does
I have some
matter.
interesting
All right.
stuff.
Yeah, it
Okay.
does
Okay,
matter.
another
Oh,
tangent.
it does. And now you're changing your tune, huh?
So
Okay.
that next slide, the comparison. So size does matter in telescopes, but we still love them both. And we can obviously see the differences here
It is so funny.
of the light capturing ability.
Yeah.
Was the Hubble's still successful? I know they
Oh
had
my-
a problem. They had to fix it.
Well,
Yeah,
that's right. So that mirror that they're showing you there is messed up, and so
Right.
this is one of the so they had to put
glasses is what he's
On
trying
it.
to say.
right because
Put glasses on the mirror?
Did you hear about that, Maggie?
No.
Yeah, they sent the shuttle up with the Hubble on it, and they deployed it, and everything was completely blurry because there was the finish or the Tom, help me
it
out.
was
So
off.
was it over
was off to-
40?
Yes, yes, it's over 40.
No, but I mean, it was off just microns, which are very small units of measure, and but it's what's known as a parabolic mirror, and the grinding of the mirror was just 2 microns off or so, and that made skewed the way that the light was traveling to the sensors, to the camera, essentially, and so it was blinded, and so they had to go up and they put on, so that the reason there's a hole in the mirror is because the mirror is shining the light to what's known as a secondary mirror, and then that secondary mirror shines it down to the cameras, to the sensors,
Through
and
that
so they
middle
could
hole.
change through the middle hole, and so they can change the secondary mirror, and they corrected the secondary mirror, and that gave the good eyesight to
So
the Hubble.
that's a pretty big screw up. Who anybody take credit for that?
That was a mess up. Yeah, it was,
Is it?
hey, this is actually called rocket science. So mistakes are made. And,
No, that's not called rocket science. That's called grinding a freaking mirror.
Which is
so-
rocket science.
Not when it's on the ground. It ain't.
When it's microns, yes, it is.
So, well,
We'll
yeah.
agree to disagree on that one.
Yeah, okay.
So we can talk about how they, even because you can't go to James Webb and fix it,
Right.
they changed the design. Are you going to? Should I talk about that now, or should I wait?
Yeah, why don't you
later?
give a talk about that?
Why don't you talk about that now?
Okay, so the you see how it's segmented into those hexagons, right?
Yeah.
Honeycomb.
And each of those is actually independent, and so as we were talking about, right, those that whole mirror thing had to fold out. It was in 3 sections, and then the mirror folded out, and then each of the hexagons, each of the honeycombs, is independently aimable. And so after it folded out, they adjusted each one individually by pointing, and then seeing what it came, hitting the secondary mirror and then coming back and to the sensors. And so they could essentially, just like they grind your glasses, they could individually, adjust the eyesight of the of the James Webb.
Yeah, so each
So it's really-
individual
really
tile
cool.
could be adjusted individually to create the perfect 2020 vision.
Amen.
2015.
Well,
Yeah.
what's interesting about just how they look is that the Hubble looks like the human eye, and the James Webb
Mhm.
looks like an insect's eye or something that has many
Yeah.
more. Yeah, I don't know if
Yeah.
that makes any sense, but that's how I
Oh,
perceive.
totally.
Maggie, this is
Yeah.
why we have you on these episodes.
Isn't it? Yeah, you've
I
seen
mean,
those.
that's interesting.
A fly's eye,
That's
you
why
know,
Maggie
that's a
doesn't
segmented cornea. You know, the
Yeah.
outside of the eye.
I
has
was
got
thinking of the
segmented.
fly. Yeah, the creepy ass looking though, man. Those are alien looking things when you magnify
And
them.
that's what she's saying. This is kind of alien looking.
Yeah.
Well, it's in outer space, so it's all tying together here.
Okay,
That's
so let's go to the next slide and skip that one because that's not important. But let's go to the next one. So Tom, why don't you talk about the electromagnetic spectrum and the spectrum of light that the Webb telescope has compared to the Hubble?
Right. So, okay, who has gone to a tanning salon?
I've walked by one.
I've only been spray tanned, so I have.
Oh, you've never laid in the beds, huh?
No, I'm too
Okay.
fair for that.
This sounds like a tangent, but I'm not sure.
No, well,
And I go to the beach a lot.
funny-
So.
Take
Yeah.
it, Tom.
And so, yeah, if you laid down in one of those sun tanning beds, you might notice that it's not that hot. It's not like being out in the sun, which is providing all the frequencies of light, right? And so, as our picture shows, right, there's a range, and it goes from the sun tanning rays, which are actually ultraviolet rays, down through the visible light, you know, all the colors, blue, green, yellow, and to red. And then it keeps going down to infrared is what it's called. And so infrared is actually what it generates heat. And so the sun is hot, but it's not the sun's heat that burns you. It's the ultraviolet that it's putting out. And
Ultraviolet or infrared?
Ultraviolet is what burns you because it's more energy. It's in the blue it's at the far end. It's all about energy, right? So as you keep going up, so as the waves get closer and the frequency goes up, the energy goes up. So if
they hit you with more energy in a shorter period of time. That's kind of what the wave things are signifying.
Yeah. Yes. You know, essentially, how much energy each photon is carrying is what it's. So if you look at that list, right, it goes up ultraviolet. Then what's the next one up on that? Right, is X-rays, right, and then beyond that is even gamma rays, which is kind of what comes out of radiation, and so that's very, very, very energetic photons. So we talked about the cooling, right? The infrared, those are not very energetic. They warm you up, but they don't really penetrate very much. They don't burn you, right? And so that's why all this cooling stuff is going on, because these photons are very low energy, need a lot of cool space. And yeah, there's a whole thing we could talk about how cold space is and all that kind of stuff. So bottom line, it is reading infrared down that 10 to the -5 meters per wave. You know, it's getting long. The waves are getting longer. Down below that is, yeah, if you keep going to the right, you know, microwave, and then down even farther, it's getting to radio waves. And those are kind of the bottom end of the spectrum. And that, as Joe said, as our brilliant Joe said, that's the electromagnetic spectrum. And that's and so Hubble works in the visible light, right? And so it's not able to see certain light that James Webb is able to see. And so and there's an interesting artifact. Are we going to talk about redshift in the universe? Or should I do that now?
I want to hear about redshift in the universe.
All right, let me explain redshift here. Things that are moving towards us, things that are moving towards us appear blue. Things that are moving away from us in space appear red. So the redshift is the stretching of these the waves, because it's moving away from us. So it's getting stretched as it moves away, and it's sending out the wave from it. When you have like the deep space field, what do they call that?
There's deep field is one of the concepts. Yeah, deep field.
Yeah, and there'll be a bunch of red things because they're moving away, and there's a bunch of blue things, and then there's all shapes and sizes and colors.
Okay.
That's redshift. It's because the object is moving away and it's stretching the light wave.
So Maggie, have you heard me? If a cop car is coming at you with a siren, it makes one sound because it's compressed.
That's called the Doppler effect.
The sound is coming at you, and the car is moving at you, and it's short, and then it goes away. And it changes sound. Do
you know that sound?
I haven't been chased by the cops that many times.
No. The problem is it's not chased by the cops, because if you're chased, it hopefully stays
probably going about the
same. Because you're keeping a good solid speed. Okay, I understand. So if it's coming towards you, it's blue, and if it's going away from you, it's red.
Yeah, because the wavelengths are compressing.
Yeah.
Coming
just like in the picture, right? You can see the ones that are closer together are on the blue side, and the ones that are farther apart on the red side. But the funny thing is that, have you heard that the universe is expanding?
No way.
Are you serious?
The universe is trending right now. Of course.
Trending. No, it's not trending. It's expanding.
It's trendy. It's trendy.
So
yes, I have heard that.
Okay, yeah, good. Because that expansion means that everything is moving away from us. So there's really no blue shift. It's all red shift. And the degree of red shift is, as Joe said, about how far and how fast something is moving away from us. But it's all moving away.
So the James Webb is more helpful to us because it actually helps us see the things that are moving away versus the Hubble, which was limited in what it could see, moving more towards us and what's visible.
Yeah, the funny thing is, the farther away it is, the faster it's moving and the more redshifted it is. And so essentially things, the Hubble could be watching something and then it would disappear because it was so redshifted the Hubble couldn't see it. So this is now bringing these things back into
yeah, and there's we're going to go over other aspects of the differences between the two, because that's only one aspect of it. But
that's important because because it's signifying that there's just a much broader view and ability to observe than the Hubble has, just because of what it can see.
Right, but let's not discount the Hubble and what it can see, which is the visible light, which brought the galaxy, the universe, really so much closer to everybody. Here's one for the Hubble, huh? Those pictures are the most astounding photos that mankind has ever seen up to this date.
In roughly, what was the heyday of the Hubble?
After they got the lenses fixed with the glasses, the first picture, it was from the first day.
Right, but what time? I mean, is that 50 years ago, 30 years ago, or 5 years ago?
That was 90, I think. 90.
It's still going. And it's supposed to have been dead. Yeah, I mean, but it's still running.
Right, and now nobody cares about it because we're having shows on James Webb.
No, that's not true. Again, because it's a different...
But when was the James Webb launched? No one knows that.
Just last year.
But right now, I mean, this is
all new. Good information for our viewers to know.
Yeah. Okay, let's go on to the next slide, because this slide shows the different timelines and different distances. And you can see that each one of these deployments is even viewing farther into the past. Maggie,
what's wrong with her? What's wrong with you, Maggie? It's called drunk astronomy, man. Are you bleeping me out?
Thomas
No.
More.
No, never.
Okay, so I'm looking at the slide.
I
Well,
thought there's only
that's
one
it.
Hubble. Why? And I knew they put glasses on, but why are there three?
Because they added, as you know, they added capabilities as they did space shuttle
Missions.
updates. Yeah, you should watch that Mission to Hubble. I think is the film.
The IMAX, right? I think.
Yeah, there's an IMAX version of it. Oh, that is unbelievable, right? Yeah, but one of the astronauts, this big burly guy, and he's standing out on the shuttle's arm. His feet are in the arm, and he's out there wrangling big pieces of the Hubble. And then they're like, "Oh, I think I broke the bolt off." Like,
yeah.
Oh,
as the wrench goes flying off into space.
No, the wrenches are attached, man. They don't let things fly
No, they've
off.
They've lost some equipment there.
They have lost some things, but I think the wrenches are attached. But bolts fly away and stuff. But because those become space junk and thereby dangerous.
Yeah,
that would be a great band name, Space Junk. Has anybody? I'm calling it right now, Space Junk.
I think that's good. I think you should play the guitar in it, Maggie.
Maggie, do you play guitar?
Yes.
Oh my gosh, she's fantastic. Oh. Yes. All right.
Really?
Let's go.
Sorry, it's my cat. Okay, I have a question about this slide.
Acoustic. Go ahead, Maggie.
Great.
So this shows that the James Webb can take images from 200 million years ago. Is that what that means?
No, it means 200 million years. Hold on, Tom. 200 million years after the Big Bang. So it can go all the way back to 200 million years after the Big Bang, which is 13.4 billion years.
Which is way more than the Hubble can, going back to 1.5 billion years.
Yes. Am I right there, Tom? That doesn't sound right.
Well, it looks like 10 billion years, right? So 480 million years after the Big Bang is because the last line is Hubble, but it's with the latest upgrades, that ultra deep field camera.
Oh, and this says the future too. I'm not sure if that is. Yeah, I don't know.
Well, because this slide was produced before James Webb was out in the ether, right?
But either way, the end result is that the James Webb can see further back in time, or
because of that redshift thing,
right?
Yeah, redshift makes things disappear. James Webb makes them appear to us, so we can see those things.
Cool.
Yeah. Yeah. All right. One more slide, and then we're going to get into some fine examples of the differences between the two telescopes.
Okay.
And this just is a little bit more of showing back to the Big Bang.
Yeah. So this is the Dark Age as opposed to the Dark Ages, right? Those are different time periods.
Right. They are different time periods.
Yeah. See, this one is showing, right, that as Joe was talking about, right, for a long time, light couldn't propagate. There was no such thing as light, essentially, after the Big Bang. It took a long time for things to cool down enough and to coalesce into particles. Really, when the Big Bang happened, there were really no atoms at all. It was all elementary particles. I mean, the physics say that it took 100 million years, essentially, for things to cool down enough so that light could propagate.
Well, you have to create a star, right? The star has to be made for light to happen.
No, can. I mean, doesn't your light, your candle, those are all making light, right? You don't need a star to make light. But I mean, stars
weren't many candles back in the day, Tom.
Well, but
right after the Big Bang.
After the Big Bang cooled down, there were hydrogen atoms, and hydrogen atoms can give off light, which you can see in stars. The stars are giving off a lot of it, but hydrogen atoms by themselves, when the two hydrogen atoms hit and they gain energy, then when they lose the energy again, they give off a photon. This is how
fair enough.
Light happens.
We're all learning.
Can you show us that equation quickly?
Yeah. Sounds like a space firefly. Is that what they are? Yeah, fireflies. Yeah. All right, let's go to the next slide, because this is showing really the difference between the two and their capabilities. So, Maggie, can you guess which one is which?
Well, I got a hint because at the bottom it says visible and infrared. So
Yeah, good job.
Wow, that is very intuitive. That's smart.
Yeah. Well, he's learning.
And so which is which?
So the one on the left would be Hubble, and the one on the right would be the James Webb.
That's right. That's exactly right.
So, and Joe, why is there such a difference between those two pictures?
Because one shot in the infrared.
And what does that mean?
Well, there you go. That's exactly right, Tom. That means that it can see through all the dust and debris of the field. So on the left, we're left with only the outer shell of what's facing us, the facade of this huge thing. Whereas
still beautiful,
absolutely,
and important,
and very important,
gorgeous. It's really pretty.
But on the right, with the James Webb telescope, you can see through the dust. So this is where the star forming happens. So you can, and that's the big, that's a big part of the excitement, is seeing the star formation
itself.
Yeah, itself, and the different stages of that formation. So which we've gone over
on the left, do you see how the lines are kind of glowing? The edges are glowing. That's because the gas is being lit up by the stars forming
from the inside.
So that you can't see the star that's being formed. And so on the right, you can actually see early stars being formed.
Wow.
Yeah. So pick one of those out. The edge, there's like that straight line across from lower right to upper left. There's the outline of the dust clouds. What lines are you talking about?
Yeah, so if you start at the top, right, this is called the pillars of creation. Is one of the things, and that little finger that's sticking up, I think that's 3 light years long.
Yes,
it's a very big structure, and so just how it's outlined, you can those outlines are the light from the stars that are being formed behind that dust cloud.
Gotcha. Yeah, it's the same thing with the wing structure to the left, I guess, of that, the way we're looking at it. And the edge of the wing thing is lit the same way Tom's talking about.
Yeah.
You see that, Mark?
All of those lines are.
Yeah, so those are, okay, so interesting. All right.
I just think that the thing on the left looks like a alien of some kind. Like I see the head and the little top of the head.
It looks like a lot of things.
I just think, has anybody put the two of them, superimposed the two images? Are there any?
Yeah,
that's, I think that might be...
the stars that show through on the right one picture would exactly match up on the stars that show through on the left.
It's the same image, basically, different.
Same image.
Which I think is, we need both,
That's right.
Yeah, I think we learn more and we understand more by seeing both.
That's right. The Hubble shot is, spectacular. There's, this is galactic awesomeness at its finest. But the right photo also again shows this star forming pattern and the stars that are making up of this whole thing. And basically, from what I understand, in millions of years, as the star gets going, it starts pushing away all the dust and all the debris, and then the fields start, and then the planetary disks start, and that's how the planets are formed. So for right now, it's all covered in dust, but in millions or hundreds of millions of years, it'll all be clear, and it'll just be big star fields like Pleiades, things like that.
So Tom, what did here's a real test. What did we learn more on the right picture from the left picture?
Well, I think that the big things that we're learning are about, and I think that this is not probably not the core of the science that James Webb is supposed to do, right? That this is just an understanding of the differences between the visible light photography versus the infrared light photography. But in the Hubble being able to see through this gas or through the dust is going to be able to see into deeper structures. And the reality is that there's lots of science. Like, for example, Joe was talking about how we measure the age of the universe, and one of the things is concepts is we need what's called the standard candle, right? So to see how far away something is, you have to know how bright it is to see. Well, it's this. Go ahead.
Quasars.
Cepheid variable quasars. Yes.
Oh,
yeah.
Cepheid variable.
Partial credit for Joe.
Partial.
Full credit for Tom.
How many?
Cepheid, whatever the other name was.
Quasars are throughout the universe, right? And then that allows us, because it is a constant type of candle light, that the smaller and fainter it is, the farther away it is, and the closer it is. And so I don't know how they came up with that. That's a whole nother episode, I guess. But, I mean, just to go into exoplanets really quickly, Maggie, do you know exoplanets? You know what that term even means?
I am guessing, based on what I've heard so far in this episode, that an exoplanet is a planet that is orbiting a different star within the same universe as our own.
Right, exactly.
Maggie is just a freak.
The same universe, which is good because we only know of one universe. People have theorized
same
about other
galaxy.
universes.
And galaxy. There you go. Now, the interesting thing about the exoplanet discovery, and this was in the 90s, is that it was actually discovered years before. Mark's getting a plug in there. Years before they even knew what it meant. And so what was happening is when a planet is orbiting a star, and we see it from that angle, where what happens is the light dips a bit. And I think I actually have a slide of that because I was expecting that. And so they kept seeing these stars dim for a little bit, and then they'd come back up. And then 24 hours later or 36 hours later, depending on the orbit, it would dim again and come back up. And they could not understand it for years and years. And then one guy put it all together. He's like, well, that's a planet going in front of a star. It's got to be. So it went from 0 planets outside of our own solar system to now they think basically every star has a planetary system on it, which, opens the floodgates for life out there, and then humans out there as well, which is we've talked about.
Have they given a number, a total number, to the number of other planets circling other stars that we've been able to see?
Yeah, I think it's around 2,000, maybe 1,500 or 2,000. It takes a while to get all the info, but I don't think they've. Yeah, I don't know if it's 100% of the stars have planets around them, but sometimes the planets will rotate where it doesn't dim the stars from our view, because it has to go across our plane. Yeah.
Right.
But if you extrapolate that, you know how many that would be? Billions.
Well,
billions.
Yeah.
Trillions.
No.
Joe, he wants to be billions and billions. Right?
Yeah, my bad.
Yeah, edit
Who was
that.
the guy who
Work with
figured
me
that
here.
out?
Work with me here.
Who was the guy that figured out that that's why we couldn't see, or the starlight changed? Because I feel like that guy needs a whole episode.
Yeah, that guy's a stud. I think his name is Sam, if I'm not mistaken. No,
Sam.
I don't know.
When you think about it, it's not that hard. It's like, why does that star dim? What would make a star dim?
Oh,
planet,
come on
right?
now.
Oh, that's easy to say now.
Yeah,
Well, yeah,
exactly.
But, you know,
now that you know the
guys-
answer.
These guys
Every-
are pretty smart
it's
guys,
burped.
and they're like,
That's
the fact that nobody figured it out,
burping.
they're all idiots. It's just like, huh?
Every test is easier once you know the answers.
Yeah, right. The star just had a tequila and it burped.
Speaking of which, okay, let's go on to the next slide.
No, we're going backwards because that was the last slide.
Well, go on to the next slide, which is, you know, that's another pillars of creation comparison.
Nice.
Yeah, I don't have the numbers on me, but let's go to the next, the spiral
Well,
galaxy.
so
Yeah, let's
Just
go to
for-
the spiral
just for-
galaxy.
Okay, go ahead, Tom.
Go ahead, Tom.
I was just going to say the pillars of creation is just that little finger at the top. The
Yes.
whole structure there is called the Mystic Mountain.
Oh, I thought it was the Eagle Nebula. No, it's more than the Eagle.
No. This
Which
is the
one's the
Mystic
monkey?
Mountain. Is that?
Which one's the monkey head
Yeah,
nebula?
the slide says Monkey Head Nebula. So
Which
there you
slide
go.
is that?
The one, that one.
Yeah. Way to go, Maggie. She figured out. Oh no, you guys are wrong. Let me tell you what's that.
You know,
No,
No, she does that all the time.
I
think
just
that-
wanted to say Monkey Head Nebula, which is also a cool band name.
These are all good band names.
You know, we're gonna see these bands come out someday, and they're gonna thank you, Maggie.
Yeah,
For
I
sure.
would like to get some credit. for this.
Yes,
Little backstage pass something.
Yeah,
Yeah.
something.
maybe a guitar
VIP.
spot, writing credit. Okay, so let's go on to the triple galaxy there, the spiral galaxy, the three pictures. And this is what you were talking about earlier, Maggie. It'd be nice to see them together. And this
Yes.
is together.
In the middle?
In the middle is together.
Oh, that's so beautiful.
And the light and the left is the Hubble, and the right is the James Webb. And you know, the Hubble on the left there, that is one of the most famous galaxy pictures of all time. I mean,
Yeah.
it doesn't get better than that. You know, it does a little bit sometimes, yeah, but that's right up there. I mean, and this is one of the remarkable things about the Hubble, just the grandeur and of course the angle, having it be flat against our viewing.
Multi-dimensional?
So this isn't the Milky Way, though, obviously, right? Then
What, Mark?
this isn't the Milky Way.
No, this
No,
is
no.
outside of the Milky Way.
That would be this way, not this way.
So,
So
yeah,
what,
so
which
when you see the Milky
galaxy
Way-
is this?
Good question. I don't know that answer.
This is,
Joe.
I forgot to get the name.
It's a very beautiful galaxy. It's
Mark, look
really,
it up. Just
really
look up
pretty.
galaxy pictures and you're going to see this one and it'll have the name.
Galaxy 12, we'll call it.
Yeah, I was going to say it's NC 1734, something like that. It's rated.
That was the. I think that was the name of the Star Trek.
Porno?
Oh, there it goes. Off the rails.
Sorry.
No,
You
the
wanna
Star
think about
Trek,
Star Trek porno,
ship,
that'd
the
be-
Enterprise, the USS Enterprise, right? Wasn't that NCC? Some.
Oh, I think it did
Oh, yeah,
start with
man.
17. Yeah. 1735? What?
No.
Okay, let's look at the next slide because that is
Can I ask a question about this current slide, though? Whether or
yeah,
not it's
sure.
good for the show? Why on the right? So we can see on the right from the Webb telescope this really blue part, but I thought we weren't detecting blue with the infrared. I'm just curious why I'm seeing blue.
Good. That's the funny thing, right? Infrared is not visible.
Right.
So all of these have to be fake colored in, right? So they choose a frequency and say, hey, this is the real, this is the color we're going to assign this infrared color that nobody could see if we put it in infrared.
Oh,
Right.
so this is okay. So, and who decides that?
the scientists.
Yes, they have a designer. What
The smart guys. They're like,
They
blue would
do.
look really good here, like really help contrast against the black. No, but I'm just curious. So it's not, so that's okay. I struggle because it's not something that's visible to our eyes. So
Right.
Yeah,
They show black
exactly.
picture. Hey, what is
It's
colorless.
called false color imagery, right? You know, that the colors are not that are not visible light colors.
okay.
They're and actually even the Hubble often has colors shifted.
Okay.
Just because they're trying to highlight the unique aspects of it, and
Okay.
so there's colorization. You know, in the movie world, they call it colorization.
Okay.
How
Thank you for
how you
explaining
can
that.
watch.
I was just curious. I'm just
that
trying
is
to
a very
understand.
good question. And insightful that you figured that out. I didn't.
Yeah. Does this Spiral Galaxy remind you guys of any other episode we've done on anything at all? Maybe.
Is that a leading question?
Fibonacci, maybe.
Have we done other?
Fibonacci, oh.
We've done other episodes.
Okay, so they've pointed these things at planets as well.
Cool.
And can anybody besides Tom name this beautiful planet we have here?
I'm going to change my guess. Neptune.
You got it there. That's a good guess. What did you change it from, though? I don't understand.
Well, I said Saturn to start with the rings, but
yeah.
The big like cloudy thing on the left on the Voyager was.
I'm gonna go Jupiter.
And it's Neptune.
Oh, it's off. Oh, okay. Well, I thought we were still guessing.
No,
You
said
were.
Neptune was right.
You were guessing.
Oh.
Yeah.
Sorry.
Jupiter's red and orange with the big.
I didn't want Mark to be right. Okay, I wanted him to be wrong.
Whoa.
All right.
What is that about? Let's delve into that, Maggie. What?
Yeah, no, this is not
pisses you off. Pisses you off so much.
He just says it with such authority, so quickly. You know, I just wanted to have it.
My sense is that he said it after searching.
No. I got the Saturn thing. I've seen the picture of Saturn. Let's put it that way.
Well, but this is not Saturn.
That's not Saturn.
You guessed something else.
Oh, I'm sorry. Neptune. I've seen Saturn and I've seen Neptune and.
I've seen Saturn and I've seen Neptune.
I've seen Saturn. I've seen Neptune.
I've seen sunny days when I thought that Saturn would never end.
When Pluto was still a planet.
It still is a planet, damn it.
Sorry. Okay.
Well, so with the planet here that we all have decided is Neptune, which is one of the most beautiful and underrated planets, I think, really. It's got tune in it, too. It's nice. You know, that's space music right there. You got to have
underrated,
a band in space. It does show different elements. And while Mark was confusing the rings of Neptune a little bit, those aren't really visible rings. So what would that be, Tom? What are we looking at there? That
yeah, I would assume well, bottom line, they're giving off infrared photons and not visible light photons, right? So that probably means one is that the planet is so far away and the rings are so ethereal, so filamentous, so that they don't really reflect visible light. They reflect reflect in the infrared.
It almost looks like there's moons circling that. I mean, there's two big bulges there.
Yeah, I see that. Yeah.
I couldn't think of any other name. Sorry, Maggie. I know you're eating.
We're losing Maggie.
Yeah, well, I love Neptune, and there's a lot of obviously life on Neptune because you can see it in that right-hand shot of all those cities. So just leave it at that.
All the cities? What are you talking about?
I'm just kidding. Yeah, it looks like
that
there's.
shot that where they show it.
We need to do a reboot of David Bowie's Life on Mars and make it Life on Neptune.
I think that's right. A definite sequel right there.
Okay.
Yeah, somebody told me that Neptune has 14 moons, so those definitely could be moons.
Now, how'd those form, huh? I wonder. See, that's the thing. Were those impact too?
That's how you get a following, Joe, is you post a big thing about your moon formation theory,
conspiracy theory,
and you'll get attacked like 1,000.
Yeah,
good. We did an hour and a half of moon theory. It took that I
well, have you
spelled
seen
it out.
The new model? Have you seen the new model?
It's still collision, right? Something?
Yeah, the moon was formed in an hour.
Yeah, no, wait, no.
By God?
No.
I know it's a model, Okay, sure, they can make that model do that. That's a different episode. That's a different episode.
I feel like I'm not on the telescopes at all anymore, so
I see.
Well, we are kind of going.
We have degraded. Well, yeah, 12 Chandra is an X-ray observatory. So remember how we talked about the electromagnetic spectrum and visible, ultraviolet, then X-rays. And so they're very energetic photons, so much so that you can see your bones, photons. And so Chandra X-ray Observatory is taking that picture of the galaxy in X-ray. And then Hubble is taking a picture of the thing in invisible light. And so they've got all the dust.
Okay, next slide.
Okay, so let's go to the right of the Chandra and the Hubble one. And
sure.
What that is showing is the ability to resolve, right?
Yes,
so
right.
The hub, because of that big old, the mirrors, the size of the mirrors, the Hubble being small, the Webb being big, what Hubble just sees as a smear of a lot of light, Webb is able to resolve down to a point. So that's what that's showing.
Host galaxy quasar, what is that? Plus quasar, what does that mean?
That's that quasar, that sun, that candle that's constant throughout the universe. So that's the focal point of the picture.
But they put that in just to give it scale, kind of thing? Light scale?
So you're saying that size
I see.
does matter. Once again.
In telescopes. Yes.
And there are crazy quasars out there that are helping to resolve images.
This is the point where it becomes drunk astronomy.
All right, so let's go to the next sombrero. Well, that's not the Sombrero galaxy. It's just another galaxy, which is really cool.
So, Tom, here's a question. Aren't they all spiral galaxies? Right? They all revolve around the black
Well, they all
hole?
start that way, but they're, again, through gravitational phenomena, they're not, because other galaxies are pulling some. So some get stretched, compressed, combine. Some are like this, because they're actually combining right now.
I feel like you're voguing. We're just
But those are pretty good at this. I never knew how good I was. Wow.
But they're all spiral galaxies that now run into each other then.
Yeah, I think so.
And we got other than spiral galaxies.
Well, there is a chart of a bunch of different, 15 or 20 different types of galaxies.
Tom?
I'm seeing elliptical, irregular, spiral, and peculiar.
Okay, 4.
Elliptical and spiral are different somehow?
Elliptical is elongated, right? And spiral is...
Well, there are some that I've seen that just look like a cloud, right? That they haven't formed the arms.
Okay, well
I agree with Joe that might be because of when they were formed, they didn't really, they just were a cloud that started spreading but not forming arms.
Or they
You call
haven't
those cloud galaxies.
they haven't
I don't
got
think
to
that's
that
a
point yet.
galaxy.
It's got
I'm
to
gonna
cluster
eliminate
up
that.
and then rotate. That's what the black holes do. I think that's what black holes do at the center of the galaxy, is to create this whirlpool around something.
So there, I'm now in my Google search here. It says that 77% of galaxies are classified as spiral, but and that the galaxies are classified by their main component. So it can be a disk, or some are actually a bulge, they say, or a halo around the center. And so that's what the internet is telling us.
Do you think that maybe we've identified so many galaxies as spiral because that's what we've been able to see so far with the technology that we have, but there are potentially many, many more different shapes that are because we're just getting technology like the James Webb Telescope and able to, see infrared, that we'll be able to learn that there are different shapes.
Well,
shape form.
I think that's might be very insightful, but I think that the reality is that everything is formed by gravity, right? So it's all of this attractive force. And so the question is, as things move and attract, then it does spin very much.
The spiral. Got it.
Yeah.
Okay.
Yeah. But I always love the fact, our current research says that our star is a third generation star, right? The sun is a third. So the first generation of stars formed, and they were very big, burned out really fast, and then they exploded, and then a second generation formed, and then now we're in the third generation of stars. And so the formation of the galaxies has gone a long ways, right? 13 billion years is a long time.
Mm-hmm.
We're on Gen 3. That works for us. That's good. Some upgrades. Some new.
I don't know
Exactly.
if you've heard the song 3 is the magic number, but Full House Rock called it many years ago.
Well, it's funny because the first ones were just the first elements that were formed were helium and hydrogen. And if we were in that generation, we'd be very light and not very
and have very high voices, I think. Very high voices.
so that, and it took some it took some explosions to make this stuff, So
wait, okay, I'm gonna show my ignorance right now. What's the third element? Oxygen?
Lithium. No, oxygen is 8. Lithium is 3.
Oh, so lithium. Okay.
Now that is a song.
By a very famous band that I really like.
Very famous band.
Hydrogen was the primary molecule or atom. Then they combined and started to form helium, and then helium burns for a while and forms lithium, and then it gets a little more complicated after
the majority of. Go ahead, Maggie.
I just was thinking we should do an episode on elements because this is very entertaining to me.
Well, so it's interesting. And it's funny because Mark, this is one of the areas I think that Brian Greene got his facts wrong, was about how the heavier elements are. So stars can create elements up to iron, but when they get to iron, so hydrogen fuses to helium, helium fuses to lithium and beryllium, moves on up the thing to oxygen. But when it reaches iron, which I think is like 38, the star explodes immediately. And within a day or two, as soon as it starts fusing to iron, the fusion process breaks down, the star collapses and then explodes. And so elements heavier than iron are problematic, and they were trying to figure out how to make them. And so they just saw this 2 neutron stars. So a neutron star, depending upon the size of the star, when it explodes, it can make a black hole. It can make, it can just blow up into a supernova, or it can make a neutron star where it's just neutrons. It's very compact, heavy. And so these neutron stars are floating around, and some of them are near each other, and so they start spinning and spinning and spinning, and then they explode. They merging of black holes, it's called. And that recently happened in a way that we could see it, and saw it with the laser interferometry gravitational observatory, by the way, because it's so powerful an explosion that it rings the universe like a bell. And so the gravitational waves float out into the universe, and these observatories are made to see the gravitational waves. And so they then said, oh, there's a neutron stars merging. And so they looked at those, and they saw a process that's called rapid neutron capture. And that is a way that atoms add in neutrons, and then the neutrons transition to protons, and then it makes heavier elements. And so this one neutron star merger, these 2 neutron stars merged, it created 200 Earth masses, the weight of the Earth in gold, and 500 Earth masses of platinum. And so I always think a lot of wedding rings just got created.
We just got to go mine those.
Be a space pirate, I would be swimming in successful capture and booty.
There are literally people thinking about that.
Oh yeah. I mean, they're planning on it. They're more than thinking.
Yeah. One being Elon Musk.
I was gonna say Elon Musk is probably already thinking about that. Okay.
You'd be a great space pirate, Maggie. I know that. You'd look really good in those hats.
I just want to have a reason to wear a patch.
She wants a space patch, though.
Yeah, and a space parrot.
I can see the graphics already. I can see them now.
I'm sorry. I know. I'm sorry.
No, it's great. It's wonderful. Well, that kind of, we do have some more slides.
Can I look at them?
We didn't talk about enough about the cooling systems and the cooling, how cool, the James Webb has to be
Tom, tell us all about the cooling systems of the telescope. That'll be really exciting.
You've got 30 seconds.
Let me tell you about the cooling systems, right?
30 seconds.
30 seconds. Well, first of all,
I'm interested.
Yeah. Well, it started with 5, so it's counting up. Okay. The tequila is affecting me.
You're kidding.
Okay, so the end of the day is that the Hubble is always going to be the OG of telescopes because it provided us with some amazing imagery that we never would have seen before. But now
yes.
we got the James Webb that can add even more depth and age and time and complexity to our understanding of the formation of the universe.
Let's drink on that.
Cheers.
Cheers.
Shot time. If we go down 2 more slides, there are some oddly shaped galaxies, which you were talking about earlier, Marvelous Mark.
The one that looks like jellyfish, number 15.
Yes, exactly. Yeah, those are some oddly shaped galaxies. That's it.
Oh, that's it. Okay, so the end of the day is that the Hubble is always going to be the OG of telescopes because it provided us with some amazing imagery that we never would have seen before. But now
Yes.
we got the James Webb that can add even more depth and age and time and complexity to our understanding of the formation of the universe.
You know, if you do one more slide down from the weird looking galaxies, this is one of the deep field shots, and every little dot there is a galaxy, of course.
Amazing.
And you know, they pointed this deep field. It was a little section of the sky where they didn't think there was any stars or anything at all. It was completely black to them when they were looking and observing. And so they said, well, let's just take a look at this black area up there, that there's nothing there. And here it goes back to almost the beginning of time, this one little area. So it's incredible. And this is in 3 dimensions, right? So that's all around. It's not just one direction. Tom, you wanted to interject?
Yeah, I heard an interesting thing that if you put a grain of sand on your finger and held it at arm's length, that would be the size of the space you're seeing here.
Huh. Yeah.
Wow.
And so this is, you know, again, to bring up other points of my thoughts are that that's why there's other humans, there's billions and billions of planets of life. And so the what is that, the Fermi's equation, Tom, or something like that?
Wasn't Drake?
The Drake equation.
Drake equation. Yeah. I think that's, you know,
that's some extra bonus points right there.
That's pretty good. That's pretty good. That's why you're sitting in that producer seat, buddy.
I thought you said drink equation.
Oh, did I mispronounce it? You guys didn't hear drink equation?
That's the D word. And so that's why I think the Drake equation is way, way off, because this is before exoplanets, right?
The Drake equation doesn't have any coefficients in it. It just has the terms, right? So it meaning that it just describes the factors that might go into how we would calculate life. But, you know, like you're saying, how many stars have planets, right? That was one of the coefficients. And so, you know, how many galaxies are there? How many? So the Drake equation's got like 14 different terms, and it's how you define the coefficients.
But, you know, after the equal sign of the Drake equation, it was something like 200 or some bull.
Well, that was one person's way that they stacked the coefficients, but that's the big challenge. Is it's been very unknown, right?
Alien behind you, Maggie. Don't look, no.
It's gonna eat your face. Oh my God!
All right, kids.
All right,
Mark, wrap it up.
All right. Well, here to wrap up our wonderful episode on the James Webb Space Telescope and a lot of other ramblings is the Drunk Astronomy crew, consisting of, we're going to give Maggie top billing tonight because she doesn't even need a nickname. Jupiter Joe, Atomic Tom, and I am Marvelous Mark. Thank you for viewing, and please send your donations to my website.
Thank you for supporting the channel. We're working on merch, and we'll see you next time.